So in this presentation, I'll mock up a refuel mechanic, but I'm going to jump back to my rocket in order to do this. Now, there's no reason that I have to do this on the rocket, but I like the continuity and the mechanics of the rocket as it relates to a refueling mechanic. Um, so right now I have the ability to, launch and fly my rocket. And by the way, I haven't integrated sound yet, and I haven't integrated any special effects or animations. So I'd highly recommend, making the gameplay more immersive by, adding sounds that support the user input, that punctuate and reinforce feedback for the user. I won't demonstrate that, but obviously on the thrust state, we could, play a sound, a looping sound that is the thruster burning, and we can turn on a particle effect that is showing a thrust effect, and maybe I'll walk through that a little bit later in a later presentation. But you can start kind of layering some of the concepts that we've looked at in previous classes and in previous presentations. But what I'm most interested in doing right now is making kind of a more comprehensive setup for the player experience. So right now we just kind of have this debug built in to where we're subtracting fuel from the player fuel, and this is just a hard value that I'm manually building in. But what I'd really like to do is I'd like to set up a variable that is a burn rate. So maybe in this game, a larger game, we have different vehicles that we could pick up, or we could modify existing vehicles and we can upgrade. And so maybe we pick up or build parts, collect parts for a more efficient engine that would cause our fuel burn rate to burn slower, therefore giving us a greater range or more capability. Or maybe we want to have more force or thrust being added when we're in our thrust state. And so if we're going to modify those values, we want to start thinking in terms of variables. And so rather than doing this hard value of -50, I'm going to create a variable, and I'm going to create a new variable, and I'm just going to call this fuel burn rate. Okay, so I have my fuel burn rate, and I'm going to go into this variable. And again, this could have been a global variable, but I want to start thinking in terms of local variables. There are some advantages of working exclusively with local variables. You just have to jump through a few hoops if you want to target other objects. But it can be a useful thing. Now, if I had a player manager, which I should set up, then we could attach this burn rate to our player manager, and then we could kind of establish all these variables in the front end. But I'm basically going to use my FSM thrust mechanic as kind of my fuel manager, my fuel burn manager for now. So this variable, my burn rate, I'm going to set a default of negative, let's say 50. That's really super high, but I want to do that that was the same value that I was burning at before. We'll go back to state, and so we can see that we basically get the same result that I had earlier in the demo. But I left it at such a high rate because I actually, want a little bit more capability here while experimenting with these mechanics. But I want to create an init state for my player so that before we get to idle, I want to pass through a state that initializes some of the basic parameters of my player. So I'm going to add state, and I'm going to call this init. And now this is short for initialization. And I will add a transition, and in this case we're going to do a finished transition and just pass it right to idle. So in other words, when we start, we want it to pass through init and end eventually at idle, where we kind of do whatever we're going to do. But by passing it and setting this as the start state through init, we can do things like setting our initial values. So maybe we want to set the player health. So this is very similar to what we did in the island project. But in this case, I want to set some floats. So I'm going to set a float value. And the float value that I want to set is my burn rate. And I want to set my burn rate manually to -10, or whatever we want our burn rate to be. It could be anything. But my default value, I created the variable, if I can find it, there it is, at -50. But once it passes through a nit, it's going to downgrade that or increase that value to -10. So it'll burn at a slower rate. And by having this init, we could set the player health, we could set the initial fuel value. So in this case, let's do that now. Let's set another float value. And this time around, we'll do globals, and we'll say player fuel, and we'll just ensure that the player fuel is set to 100%. Now, we don't need to do this every frame because we're just going to set it one time and pass it over here. So now we know that the first time we get to the idle state, we know that our burn rate is -10 and our fuel is 100. And so we don't have to, if we start referencing those values in other mechanics, how much fuel do we have? Are we adding to fuel? Are we, burning at different rates because we've powered up? We don't need to reference those hard values and check those across multiple states and multiple state machines. We can simply just refer back to these variables. Okay? So we're initializing these. We're passing it over to idle. So we got a pretty decent setup here now to do a real quick pickup. So I'm going to wireframe this with a cube. I'm going to throw a material on it so it stands out a little bit from everything else. And I'll just throw let's see, red kind of implies it should be a bad thing. So I'm going to throw a green material on there, and we'll call this refuel cube. This is the refuel cube. And I'll just move this over a little bit and move it up. And so in this case, if I collide with this thing, because this is such kind of a sensitive physics-based game, this thing's going to be floating in space, we have the choice to interact with this either based on collision, which I just bounced into it, or based on a trigger event. And then, in my opinion, in this case, this is a great place for a trigger event instead of a collision event, because even if we're colliding and eventually destroy this object, it could influence the path and the trajectory and the motion and the physics of this object, of our player object. And so I'm going to mock up this mechanic, this pickup mechanic, to refuel based on triggers instead of collisions. So we have an idle state, and what we'll do is we'll listen for some physics interaction, and we're going to listen for a trigger event. So I'm looking for trigger. There it is, trigger event. And on trigger enter with the player, so I got to make sure that I'm going to tag this with player, and then I need to make sure that this is tagged as player. I'm going to send off an event, and we'll just do a real simple generic next event, and we'll add this next event as a transition and pass it to another state. We'll call this the refuel player state. Okay, so if we have a trigger event with player, if we have a trigger interaction, we're going to fire off the next event. The next event tells it to refuel player. So what we'll do is we'll do a float add. And we'll add to the current value of player fuel. And let's say that we'll earn 20 points of fuel. We don't want to do it every frame. We don't want to do it per second, not in this case. And then we can destroy or deactivate the game object. Now, I'll say destroy, but creating and destroying objects, if we're doing just a few of those or a few hundred of those, and we're not doing it in rapid succession during our game, not a big deal. We can create and destroy objects quite efficiently. But if we're like making a projectile-based game where we might be creating a lot of projectiles and doing a lot of different calculations and having more complex mechanics on each one of our game objects that we create, it's always best to deactivate and reactivate objects rather than destroying and creating. And this concept is referred to as object pooling. And it's really kind of offloads some of the heavy lifting of game object creation so that things run more efficiently, and that the resources of the device or the system that you're running on can focus on running the game rather than creating and destroying objects. So keep that in mind. We'll take a look at those issues in future game design classes. But for now, we're going to just destroy this thing. But I want to get this order of operation right. We run the risk of destroying the object before we can do a float add, even though it should work. I'm just going to make sure that we do a float add first, because these do run from top down in order. So we're going to float add to the fuel player fuel, excuse me, and then we're going to destroy the game object. Okay, now this isn't going to work, not yet, because I have not set the collider to use a trigger, so we still bounce off of it. So that's a sign that it's not set as a trigger, and we are listening for a trigger event. So I'm going to go find our refuel cube and make sure that the box collider is listening for is trigger, and then I'll test this, and it may not work, and if it doesn't work, it's because my Rocket 2 object is not yet tagged as player. So I got to make sure, because remember, over here I'm listening to whether this trigger event collides with an object that's tagged with player, and it wasn't going to be because it was set as untagged. But right now we can fly over, and we've just earned more fuel. Okay, so we can we have that basic mechanic ironed out, and I can see my fuel, sort of. Okay, I'm about to run out of fuel. Oh no, gonna crash. And I have not put any more fuel over here, so I'm totally doomed. But that's okay, because we're still just mocking this thing up. But I could take this refuel cube and I could duplicate and move that over, and that, that's scalable, right? So let me mock up just really quickly an alternative which would give us the ability to land on a hotspot that would refuel us over time. Now, this is something that it's equivalent to something that we've looked at in the past of taking damage while we're interacting with a surface or an area, or a danger zone that we establish. The only difference is that instead of taking damage towards health, in this case, we're going to increase fuel. And so I'm going to mock this up just really quickly with a cube object, because I like using cubes to wireframe things. They don't take much time to create. So I'm going to scale this probably to 5 along Z and X, and I'm just going to set this into the ground. So the idea here is that if we land on this thing, while we land on it, I want to refuel. So this cube, we'll call this is the fueling landing pad or fueling pad, whatever we want to call this. This is the fueling pad. And what we'll do is we'll add a state machine to it, and we're going to build a simple 2-state state machine. We're either going to be idling, or we're going to be refueling. Okay, and in this case, it implies that we're refueling the player. Down the road, as our games get more complex and we build AI into enemy objects, potentially we could have those enemies also consuming fuel and looking for landing pads and trying to land and refueling other things. But right now, we're just going to refuel the player object. So in idle, we're not going to do anything, right? We're just going to idle. However, we do want to listen to some interaction with the player. So in this case, we could set this up as a trigger. But I'm going to set this up, just leave it as a collision. So I'm going to search for a collision event. And on collision enter with the player, we're going to want to send it to our next state. So I'm going to use that next. I'm just going to create a next event. Got a typo, so I'll go correct that. I could correct it after the fact, but I'm going to change it now. And so when we on collision enter with this object, we're going to fire off this next event. Now, we've had this problem in the past before, that if we do a collision enter here, it should work, but we could skip off this object potentially. So we could change this to on collision stay, which is really going to react pretty much the same as a collision enter here. But on stay is basically checking to see, okay, are you already on the collider? Are you currently on the collider? So it's a little bit different than have you entered collision. So collision would be on the front end. So you enter a collision, you stay on a collision, and then you can exit a collision, among other things. But those are kind of the three different states of collision detection here. So on idle, we can collide, and we'll pass this over. So we're colliding with player, and we'll pass this over to refueling. Now, what I want to do is I want to build my collisions to work first. And on the case of refueling, if we on collision exit, so when the player leaves, we want to pass it back to idle. So say on collision exit with the player, we'll do a next send event, and we'll wire that next back to idle. And so we should, if I set this up correctly, we should have a simple mechanic that when we land on that landing pad, if I can land on it, we're either refueling or we're not. We're idle. Okay, we're refueling or we're not. Okay, so once we have that worked out, all we have to do is on the refueling state, we want to increase our player fuel value. So we'll just do a same thing we've been doing. We'll do a float add. See a pattern here? We'll do a float add, global player fuel, and we're going to add at a rate. Let's add 10, positive 10, every frame per second. Okay, so we can burn fuel. We're burning, and we come down, and now we land, and we're refueling. I can see my fuel going up. Now I'm going past 100, so maybe one of the mechanics is that, you know, my default tank only holds 100, but I can upgrade it later on by whatever, make a, you know, making a larger scale game where we can upgrade the fuel tanks and then therefore hold more fuel. Lots of things that we can do. But if I want to max my fuel out at 100, a real simple solution for that would be clamping the float value. So give it a minimum and a maximum that it can't exceed. And again, we're getting into this area of this would be really cool if we had a fuel manager or a player manager that would manage this stuff, because now we would have kind of a central location. But this is basically a player mechanic, and it's basically, we've built it in as part of the thrust mechanic at this point. And now you can start to see why we want to start naming our FSMs. So this is our FSM player torque on our player, and then we have our FSM thrust. And so basically what we want to do here is we want to not allow our fuel to exceed 100. And this is, you know, kind of in a tricky space here, because we could be idling and we could be thrusting. Could be idling, could be thrusting. So we'd have to clamp it in two different states if we're going to clamp this thing. Or we could adopt the player camera, which is, you know, in this case, a simple solution because we already have a state machine that's following the player. But now, you know, we're kind of getting into this realm of a player manager again, where, you know, should that be attached to a camera? I don't think so. I think it should be an empty game object, but it's a little outside the scope of the demo of this review. But as you encounter these kinds of things, okay, well, now's the time to make a player manager or make a player fuel manager, or and start to create those individual game objects that manage. But for the sake of the demo, I'm going to borrow our camera, and I'm simply going to do a float clamp. So I'll search for clamp, and there's float. This will be running all the time, and we'll clamp player fuel, and we'll say the minimum value can be 0 and the maximum value can be 100, and we'll clamp that every frame. And so now we'll find ourselves in a situation where we can't exceed 100 as far as fuel goes, because we have it clamped. Okay, that's just a simple way. Now, there's more efficient ways to do that, but you can see now we max out at 100. Burn fuel, and in fact now we won't go into that negative zone, crash. We won't get into that negative zone the same way that we did too, because we're clamped to a minimum value. Okay, my rocket's stuck. So obviously I'd want to reset the game at this point. We could listen for velocity. Is our velocity at 0, and is it at 0 for a certain amount of time? If so, reset. Or did we collide with a collider that would only hit the ground if we're sitting sideways, right? So in other words, if I look at my player, not a player camera, my rocket, there it is. Right now I have 2 colliders on my rocket, but it'd be really cool if this collider, I could talk to a little bit separate from this collider and say, look, did that collider hit the ground? Because I know if that collider hits the ground, I'm in big trouble. This one's okay because I could foresee landing somewhere, and I could foresee coming down to the fuel pad or doing some things or running into things. But if this part hits the ground, we're in big trouble. So we should explode, or we should lose health, or we should respawn, or whatever we should do. So, in that case, we'd probably want to set up something a little bit different. And in this case, we could probably just mock up something really simple, like creating a cube, and this cube object would be our, this could be our ground test object. Let me zero this out a little bit and move it up. I'll just move that up right there. If this thing hits the ground, we're in trouble. We're in big, big trouble. Okay, so we could set up a little mechanic that says, if we collide with the terrain, well, we've exploded. Okay, and we don't have to see that. We could turn the mesh render off, and it could just be a collider that's there that we know that if that hits the ground, we're in bad shape. Okay, so just something to think about. So that's the refuel mechanic. Now I do have something that's a little bit more complex in terms of the concept of a refuel mechanic, in that this refuel mechanic really started from the exact same place of the demo that I just gave, and I'm not going to walk you through everything here, but we can just walk through the logic really quickly. We have this initialization state, which in this case isn't, I always build init states into just about every state machine, because ultimately most of them are going to use some sort of initialization. And in this case, this is kind of a smart fuel pad, in that it contains a volume of fuel, maybe 100 or 10 or whatever, and once you consume that fuel, it'll go down to 0, and then you can't refuel on that fuel pad until it charges again. So the concept here is that we end up in this state that checks to see what the value, how much fuel this is holding, basically. And if it has fuel, we would fuel the player. If it doesn't have fuel, basically we're waiting a certain amount of time before it eventually slowly recharges its fuel value, and then allows the player to land on it to refuel. So the concept is here that we could exhaust the fuel, and that we have to wait a certain time before it lets us come back and refuel again. So we can't just consume it down to 0, fly away, land back on it, and refuel again. And we can't just stay permanently on this thing and refill until we reach capacity. Maybe there's a large fueling pad that's has a capacity of 100, and a small fueling pad that has a capacity of 200. And of course, these mechanics, these concepts, they're scalable, so they could apply to your balloon or your paper airplane or your light or your ghost or whatever it is that's flying across the screen for your game. But just wanted to share that concept with you, but just reinforce that concept of iterating on your mechanics, get the basic mechanic to work, and then if you have time, really refine that into something something special. So that's it. If you have any questions, send me an email, and I can address some of these questions through screencasts. But that should give you kind of some stuff to play with for this final project. Have fun with it, and I look forward to seeing your project.